Alright, hello. So I'm going to show you a little dealio with the arbitrary waveform generator. So this is something that, initially you might just think, okay, well this is good because it gives me at least a function generator, which is true, but the real power is that you can do whatever you want. And the unfortunate thing is that the arbitrary waveform generator is really just as good as the software you have. So I've had a previous PC-based scope, and the company never ended up delivering by a different manufacturer on the AWG. So you could always do sine and square, but you couldn't really do fun arbitrary stuff. So to start with, they do give you some pretty useful things. So for example, there's a white noise feature, which if you want to analyze some stuff in the frequency domain is kind of cool because it gives you a source of wideband noise. So the noise is designed to go up to, I think, 20 megahertz. So you can see here's a much wider spectrum, but for that first little bit, it's quite good and quite flat. So there we go. There's over 20 megahertz. It's quite nice. There's sine. You can look at everything in the frequency domain. There's a pseudo-random bit stream sequence if you want to do testing of digital systems, so you can check the input-output. But what I want to show you is the actual arbitrary part in the arbitrary waveform generator. And I'm going to show you one sort of fun thing you can do is I showed you before this serial decoding example. So what I'm going to do is use the same setup and I want this on, let's just do a single waveform. So I'm going to send 4 A's in a row, and I have a serial link here, so I was just using this on channel A. Oops. And why is it triggering? Because it's set wrong. So let's do that again. And I need to be way out here, so I just have to do a bit of setup. You could use the setup wizard if you wanted, of course, for this, but I just had it set up, so. Alright, so there we go. So we've now captured our waveform of interest. And let's just use a zoom to window. Take a look at that. So that's our serial data. And I want to play this back, and maybe I want to vary the frequency because I'm trying to validate some receiving routines I've written in a microprocessor, and I want to know what's the limit of the frequency they work at. So I've used the rulers here that you just pull over to select the area of interest, and I'll start up the arbitrary waveform generator, and I'll say arbitrary is the type, and I hit this arbitrary button, and I load. So there's this little button, import from channel, and this just takes the data from channel A I've selected between the rulers, and it's saying it'll import 2,861 samples. So I guess it's entirely based on what the original sample rate was, which was this 9.766 megahertz. Anyway, ignore me. So there's the waveform I have, and I'll hit OK, which will load it into the arbitrary waveform generator. So let's just get a look at what it's sending by looking at channel B here. So it's just sending this on repeat, and what you may have to do is try to figure out what the frequency mapping was. So there we go. So obviously you can increase some of the dead space if you want. So let's say I want, okay, and what we want to test is the frequency that we're actually running at. So I can just do this on repeat. And what I'm going to do, the easiest way to do this is I'm just going to use the serial decoding built in. And so this is 57.6 kilobaud. So it's just estimating based on the bit width there. So if you want, you could send stuff back, and you could choose, there's 57.6, what you wanted. And the cool thing is, of course, that because this is generated through the arbitrary waveform generator, I can change it. So I can try different frequencies. I can change it just by small amounts. So I could change the base frequency there, and then when you do the serial decoding, it's a slightly different baud rate. So this is good because if you're designing any sort of serial I/O routines, you might want to have an idea, well, how close, how good are they at actually working if the baud rates are slightly off. So using the arbitrary waveform generator is a really easy way to do that on the PicoScope devices. So that's just sort of one idea of why you might want the full arbitrary waveform generator versus just something like a simple sine, square function generator type deal.